talk to Acme site. Acme sites. You know what? I'm just going to do it again. NAT outside source dynamic. If it's coming from this object group, I'm going to NAT it to this object group, right? And destination is also going to be static. If the destination is, where's my 10200? So let's just grab everything here now. Right, so say allow access to Acme AWS sites. What errors am I getting again? It says what? Oh, did I just say this underscore 32? I think. Say show run objects. 10 200 210 underscore 32. Did I not also create an object for? Oh, I haven't. So I need to say objects network, which is this, host, which is equals to 10.70.244.10 oh yeah, .10, yes. So if we go back and run this, it should take it now. Wow, it took a long time. So show run NAT, yeah. So I mean, this is what we have, right? This is the Twice NAT, which is really the reason for this video. This is actually where you have Twice NAT, right? So we are saying here that if you're coming from Frankfurt site, right, we are NATing you to this IP. So source is changing. Then if destination is this, then this is the actual destination. Yeah, really pretty straightforward. All right. It really helps you in situations where it's something it's really recommended, because especially when you want to scale your VPN and you know in the future you're going to be needing a lot of private IPs and you're going to be talking to a lot of third parties. It's always good to limit the amount of IPs that is exposed to this third party, because when you have too many overlapping IPs, it creates a lot of problem, and so it's always good to limit how much IPs you are exposing to your third-party providers, so that it gives you that leverage to use any IP within your infrastructure. Well, I'm explaining, but we have not tested. So what we need to do is we need to go back to the VPN, right? We need to connect back to where now? We need to connect back to Frankfurt, which is 1.20. 192.168.68.1.20. Okay. It's taking so much time. I hope the IP is right. Yes, 1.20. So let's see. That's my ASDM. I don't need ASDM anymore. Yeah. So let's check. Oh, it's refused to connect. So let's see. 192. Sorry, should be 168. Yeah. So that was why the delay. Okay. So we're gonna say, let me log in to the VPN. So we're gonna say route print. Let's wait for it to connect first. Yeah, so So let's just do the route print again. So I think I can delete these IPs. No, I don't want to yet because we are using them. So but as you can see, we are back to 1045, right? So let's see now. Now the destination is going to be what? Ping to 10.200.200.10. I hope it works. But we know it's 10.200.200.10, right? Because that's what we configured here, right? Okay. So what we can do is so an easy way to see it is we can go back to the packet capture and see, are we still getting, okay, there's still a ping coming from 192.168.10.10. So this is from the old pings that we did. So I need to stop some of those pings. This, yeah, so it should be this should be it, and yeah, so everything should stop now. Yeah, so you have to minimize all this out, and so what we need to do is so let's look at it from this end, the London end. So let's even see, I'm going to say clear NAT counters. Clear NAT counters, right? So show NAT details. Let's see, it's coming really large. So this is what we're interested in, right? Yeah, so this is the last NAT row that is actually doing the twice NAT for us. But let's see, is there even a match? There seems to be a match, right? There seems to be a match. So we're getting some IPs. Is there also a NAT at the top? Let's see. So so this is the manual NAT. So this is really where we're interested in, right? Now we know that this is London frac, right? We know that if the source is this, it's not translated, and if destination is this, it's not translated, and there's no hit on here, but we're having some hit here. So what we can do is we can try to do a packet tracer. Let's see. So I'm going to say packet tracer. Input is going to be outside. It's going to be ICMP, and we know it's going to be coming from one of these block, right? From frac. So it's going to be 10. Let's say 50. Right, 0, and the destination we know is going to be 10.200.200.10, which is a floating IP, right? So let's see. Yeah, we're matching that rule. Interesting. So source is actually going out, and what else do we match? We need to match something else, right? So obviously something is not right, right? But of course we see that the source is being translated, but we don't see the destination being translated. One of the things I always like to do in my NAT row is to move the more specific up. So I'm going to say show run NAT. First, just to be sure, right? Let's go back to show run object group. Let's be sure our subnets are correct. So this is 10.10.200/24. Okay, so it's part of the London to Fraud local subnets. So let's check that object ratio run objects ID this. So it's 10.200.200. So we are very sure that that subnet is correct, right? Let's also check it from the front end. So we need to say show run object group, show run objects. So we said it's going to be 10.200.200. So everything is actually accurate, right? So one thing we can do here, we can say clear crypto IPsec SA. Okay, it's just one tunnel, so it's not going to hurt. So I'm going to say show crypto IPsec SA. Okay, so there's really no encapsulation going on. So that's, oh, I think because we just restarted it. Yeah. So our packets are actually being encapsulated from the frag end, right? Encapsulations are going on towards the London end. So let's also check the London end. What do we see on the counter? So that's how let's even know where traffic is getting to. Clear crypto IPsec SA peer 192.168.1.20. So show crypto IPsec SA for the peer 192.168.1.20. Peer, okay, so 1.20. All right, interesting. So what that tells us is that the packet is being encapsulated from the Frankfurt end and it's coming over the tunnel. So let's go back to the diagram. It's a bit tricky. It's a big tricky implementation. So this is the tunnel, right? So this user comes in, remote access, and the traffic is encapsulated, right? All the way down to London. So that's why here you see encapsulation, here you are seeing the encapsulation, right? So encryption, the encapsulation is happening here. But what we don't see yet is, we don't yet see encapsulation going. So there's actually no return traffic. Now what we can do is, let's even see when the traffic hits the ASA, where does it now go to? Let's also look at the end towards the AWS site in this case. Okay, so what I'm trying to say is, remember from here as well to this end, there's also a tunnel, right? So our expectation is that the traffic comes and then it's helping out to this end. So we now need to look at this tunnel and check, is there any sort of encapsulation, the encapsulation also going on? Because we want to know, is the traffic getting there and just not being sent back, or I mean, what is really going on? So let's just look at it from that perspective. So I'm going to come here and now I need to clean this up. I wish there's a way to roll back. Let's see. There's really no way. But of course, I've already explained what we are trying to. So I'm going to say clear crypto, right? IPsec SA for the peer 192.168.1.10. Okay, so I'm going to say show crypto IPsec SA. No, let's do it for that. Show crypto IPsec SA for the peer 192.168.1.10. So it's not even being triggered, right? Although we just cleared it, but let's say show VPN section DB LAN to LAN, filter by IP address, which is 192.168.1.10. It's not up. So why is the tunnel still down? I know we just cleared it, but it's not even up. So the implication, what that simply tells us is that, you know, there's really no traffic to trigger, right? There's no traffic to trigger. So right now, I will tell you, I'm not even sure what is wrong, but let's just go back and troubleshoot again. Sure on that. So we said if it's coming from outside, dynamic, and we say if it's coming from London frag remote, which is from frag end, we want to translate it to this IP and this and this. So let's say show NAT details. Show NAT details. Okay. So we are getting translated hit, right? From this to this. So it says translated, but what we are not sure of is it the source that is being translated? So is the translation, what I'm not sure of now is Is this translation that is currently occurring, or is this the destination? That's what I'm not sure of. Then is there any other hits at the top? And so I was expecting traffic. I would have been expecting that traffic coming from FRA, right? Going to this. Okay, so here's a London FRAC local to London. So I was expecting to also see some hit count from here, but I'm not even saying it. Because we said if it's coming from this, right? Translate, don't translate. Okay, we say not, don't translate, right? So what I can do is, so I'm just going to, I want to move it up a bit, right? So I'm going to remove, I'm going to remove this, right? So I'm going to say no this, and then put it back. Let's see. Show run NAT, show NAT. Exactly. So I think what was happening before is so I feel some of the traffic, so the traffic was actually coming through this rule, right? Because this is the rule for the site to site between the London end and the Frankfurt, right? So I think the traffic was actually coming in through this rule, and so this had precedent over this. So it was like more like there was no complete match, right? I'm not really sure how to explain it, but let's see if we check. Is it working? Does it mean it's working? It's not yet working though. Doesn't mean it's working. But at least what we can do now, we can say let's do a packet tracer again and see what changes. Can I still get my packet tracer? Yeah. No, I don't think I can still go back. Let's see. Yeah, so let's see what changes. Yeah, there's some changes. Looks a lot better now, right? So it should really be, we should really be getting pings now. we should really be getting pings. But let's look at it from beginning to the end again. So what we are saying here is that if it's coming from London, right? So here you can see if the destination is this, destination is actually be translated, and also the source is being translated pretty much, right? It's a random source port number is generated. And then when you go down again, you're going to see everything is, okay, say the action is drop. RPF check is allowed. So here you see we are coming back again to say, oh, if it's coming from London FRAC, you know, so I believe it should really work. The IP we are pointing to is 1070.244.10. So if you look at all the different stages, everything is allowed. So phase 1 is allowed, phase 2 allowed, phase 3 allowed, phase 4 allowed, phase 5 allowed, 6 is allowed, 7 is also allowed, 8 allowed, traffic is encrypted. Yeah, so what we can do, let's see why the ping is still not going through. What am I pinging? 10.200.200.10, which is the right IP, and the destination it should be this 10.70.244.10. So let's just double check. Show run objects, ID, which is this 10.70.244.10. So it looks correct. So, but I mean, what we can do here is let's even look at the. So here I'm going to say show crypto IPsec SA. Let's see. Okay, so we're actually getting uh, let's see. Okay, so this is for traffic. Oh, this is in London. I want to see from Frankfurt. Show crypto IPsec SA. Yeah. Okay, something is still not coming back, right? Something is not coming back. So so I think it's still the same problem with the natural, the precedence, right? So what we can do is, let's say show run NAT. So let's take this one down as well, right? Remember, this goes to AWS. So let us sit. The more specific should stay at the top, because it's kind of, it makes it not to match properly, right? Because the traffic is coming over the tunnel. So I'm going to say no this, and then let's put it back. Let's see. Show run NAT. Yeah, so the more specific sits at the top, because it's going to, you're going to have the, so let's see. Oh, we stopped it. Okay, it's still not working. But what we can check, let's check for the frag end again. So the traffic is still being encapsulated. 108. So let's go to this guy and see what we see. So let's see. We have the London. Okay, so that shouldn't really match. So let's say show NAT. Let's see what else do we see. So we are actually seeing packets are being translated and also untranslated. We are seeing translated here. 48. So it's been translated, right? So let's also check the packet tracer. Does it get to the destination? It looks like it's actually getting to the destination, right? So because the traffic gets to the destination from what I say now. So what I can do is I can say show crypto IPsec SA peer 192.168.1.10. Now you see everything looks good. Okay, so everything looks good because you see packets actually being, yeah. So let's go back to the diagram. It's really kind of is a difficult implementation to say. So you have this tunnel that comes, you have this tunnel that comes, right? So from what we have seen now, this traffic comes, it comes here, and then it goes out, and then there's a return. But that's where you have the break now. Now for the return packet, this ASA needs to know how to forward it back, because you're doing dynamic NAT, right? So let's see what could be wrong with the NAT rules. What could be wrong that is not being allowed? So I'm going to come back to let me delete this. I'm going to say show run NAT. Okay, so let's look at it again. We said if so this sits, I think it has something to do with just the sequence numbers of the natural. I think that's really where the problem is here now. The sequence of the naturals. I don't see anything wrong with what we have done, but it's just the sequence of the naturals. Let's see. Still not going through, but let's show run NAT. Show NAT. Okay, so packets, I'm getting something from here. Okay, let's see. Okay. Oh, sorry, I was always looking at this, but this is a different user, right? this is actually the rule that we created. Now we hold on. So I need to let's just clear the xlate, right? Because sometimes if you don't clear the xlate, it's going to, even when you make changes to the NAT rule, it doesn't. Let's see. Still not working. Clear. Can you say clear? Clear NAT counters. Yeah. So see. Okay, but I'm still getting hit here. I'm not sending traffic from here, right? So why are we getting hit? Something is wrong. Something is wrong. So what I'm going to do, I'm going to take this guy and put it down. Hold on. What am I saying? Sure on NAT. Ooh, I have 2 NAT rows running. So which is the correct one? I didn't see the whole time. No, it's not 2 NAT rows. So this, I'm going to take this down again. Let's see. Because I'm seeing hit on that NAT row. Show run NAT. Okay. Show NAT details again. Show NATs. Yeah. So let's see now. You see, wow. So you really need to I'm not really sure how to explain it, but in this scenario I think there was kind of an overlap, right? There was a lot of overlap within the subnets. So what we're just getting here is this more twice NAT rule has to sit at the top, right? Sure on that. This has to sit at the top, because when these other rules sit below, be on top of this, there's a partial match, right? Either is coming from the source or from the destination. It's a bit, kind of complex to explain, but most times when you want to implement these kind of situations, always ensure they don't overlap with the other NAT rules, because what we noticed here was that there were a lot of matches to these other subnets. Okay, but I mean, yeah, we solved it, right? So this is kind of a not really too complex, but this is what you can actually do with Twice NAT, where you want to hide certain IPs, you want to be changing source and destinations. And so with this kind of implementation, you are able to scale, right? Because if in the future you have another third party that is here, you have so many third party that talks, either they talk to you or you talk to them, or you provide some kind of services here and they need to talk to you, and this could scale up to hundreds of different third parties or your customers, and they all need to come, right? So this is a good way of scaling, and it provides more efficiency, because now we are using 10.200.200.10. we can say, okay, if this customer C comes, we just pick a different IP, 200.200.11. It depends. So if here they have multiple servers, maybe just 3 servers that you need to talk to, so you just have 12, right? So that is really all we need to talk about the Twice NAT. Let me know what you think, and I hope if you also run into similar situations whereby you need to implement this kind of rule, I hope it's helpful. All right, if I have time, what I want to also talk about is port NATing, because we've not really talked about port NATing. Let me give you a scenario. Let's say I have a server here, this server, so this is my ASA, and let's say I have a server here that is FTP. Okay, now I have these users on the internet, right? So this is my public internet, right? And so they need to come in and access the FTP. Now FTP, I think it uses port 21. I'm not sure if it's secured. It's not secure. It's not. I'm not sure. So what we can see, we can tell the ASA that if somebody is trying to access this FTP, let them come in with port port 443, which is secure, and then you're going to port it to port 21, right? That's destination porting, or source destination porting, right? So we are going to just pick a scenario here, maybe one of these servers. We just install FTP on it, and then we can try to hit it. So the IP here is quite different. So it's going to NAT the public IP here. So maybe the IP here is 1. It says 168.1.20. Then we're going to translate it to the private IP, which is 10.0.0.20, like in this case. Okay, so I hope I have free time, so we're going to also discuss about that. So thank you. If you like this video, please subscribe. We try to always talk about real world scenarios, like really complex implementations that we try to implement within our infrastructure. Thank you, and I'll see you in the next video. Bye.